Hi students, today we are going to study something about oxidation number. Oxidation number is otherwise called oxidation state. So this oxidation number as well as oxidation state both are indicating the same thing. So what is the definition for oxidation? It is the formal charge that an atom of an element have in its combined state. So the oxidation state can be talked only in combined state. So formal charge that an atom of an element. For example, let us consider an element, the familiar element we know, that is sodium. So consider one of its combined states, sodium chloride. What about the charge of sodium in sodium chloride? During the formation of sodium chloride, sodium give one electron to chlorine. So what is the charge carried by sodium? So sodium is carrying +1. So the +1 is the oxidation state of sodium in its combined state. So +1 is the oxidation state of sodium in sodium chloride. What is oxidation state? Formal charge that an atom of an element have in its combined state. So it can also be defined as balanced charge that an atom of an element in a molecule have when all the other atoms are removed as ions. For example, if you are taking hydrogen chloride, so hydrogen is sharing one electron, chlorine is sharing one electron and form a hydrogen chloride. In hydrogen chloride, if chlorine atom is removed from hydrogen chloride, how can you remove? We know that chlorine is more electronegative than that of hydrogen. Therefore, when it is removed from hydrogen chloride, it will take up the shared pair of electrons. So when it take up the shared pair of electrons, Cl become -1 and hydrogen become +1. +1 is the oxidation state of hydrogen and Cl- is the oxidation state of chlorine. Oxidation state means it is the imaginary charge that assigned to an atom in a molecule. So this is the definition for oxidation state or oxidation number. The oxidation state of an element in a compound can be calculated from a set of rules. Let us discuss one by one. Rules for calculating oxidation number. Oxidation state of an element. In elementary state, oxidation state of an element in elementary state is equal to 0. For example, the oxidation state of sodium in elementary state. When sodium is as like sodium, its oxidation state is 0. If we are taking chlorine in elementary state, its oxidation state is 0. If you are taking copper in its elementary state, its oxidation state is 0. If you are taking sulfur in its elementary state, its oxidation state is 0. So whatever may be the element, in elementary state, its oxidation number is 0. The oxidation state of hydrogen in most of its compound is +1. But in metal hydrides, so what is the meaning of metal hydride? When hydrogen combines with some metal. Suppose if it is combined with metal, we are getting CuH2, copper hydride. Suppose if hydrogen combines with sodium, we are getting NaH. These are called metal hydride. In metal hydride, the oxidation state of hydrogen is -1. In all the other cases, the oxidation state of hydrogen is +1. Third point, the oxidation state of alkali metal. So what do you mean by alkali metals? We studied group 1 element. So the oxidation state of group 1 element in all its compound is +1. So oxidation state of group 1 element. Group 1 element in the sense lithium, sodium, potassium, rubidium, cesium, francium. For all these elements, the oxidation state in its combined state is +1. So what is the oxidation state of potassium in KO2? Without any calculation, we can say the oxidation state of potassium is +1. The oxidation state of alkaline earth metals. So alkaline earth metal means the oxidation state of group 2 elements. The oxidation state of group 2 element in its combined state is +2. Beryllium, magnesium, calcium, strontium, like that it goes. So the oxidation state of calcium in its combined state is +2. The oxidation state of magnesium in its combined state is +2. So the alkaline earth metal, the oxidation state in combined state is +2. Then fifth point, the oxidation state of aluminium in its combined state is +3. So in most of the compound, the oxidation state of aluminium is +3. Next point, oxidation number of oxygen in its oxygen is normally -2. So usually in almost all the compounds, the oxidation state of oxygen is -2. But in peroxides, example H2O2 or Na2O2, so these are called peroxides. In peroxides, its oxidation state is -1. So normally the oxidation state of oxygen in compound is -2, but in the case of peroxides, its oxidation state is -1. In superoxide, example KO2, RbO2, the percentage of oxygen is more than that of other element. So in superoxide, the oxidation state of oxygen is -1/2. But in the case of fluorides, so what are fluorides? So fluorides means nothing but when oxygen combines with the fluorine, the resultant compound is called fluorides. So usually we studied when oxygen combines with any element, the resultant compound is called oxides. But when we are comparing fluorine and oxygen, fluorine is the most electronegative element. Therefore, the compound formed between fluorine and oxygen is called fluorides. So there are two types of fluorides are there: oxygen difluoride, dioxy difluoride. So in the case of oxy difluoride, the oxidation state of oxygen is +2. Whereas in the case of dioxy difluoride, the oxidation state of oxygen is +1. So what about the oxidation state of oxygen? Normally the oxidation state of oxygen is -2. But in the case of peroxide, it is -1. In the case of superoxide, -1/2. In fluorides, its oxidation state is +2 and +1, positive. Oxidation state of fluorine. Among the halogen, the oxidation state of fluorine is -1/2. Whereas the oxidation state of chlorine, bromine, iodine also -1. But when these combines with the oxygen, the oxidation state become positive. That is, in the case of oxo acid and oxyanions, the oxidation state of chlorine, bromine, iodine become positive. But the oxidation state of fluorine is always -1 in its compound. The algebraic sum of oxidation number of all the atom in an atom of an element in a compound is equal to 0. So we studied in the case of sodium chloride, the oxidation state of sodium is +1. The oxidation state of chlorine is -1. What about the algebraic sum? It becomes 0. So usually in all the compound, the sum of oxidation state of all the element is equal to 0. In the case of polyatomic ions, so it is called polyatomic ions. In the case of polyatomic ions, the charge is equal to the sum of its oxidation number. The oxidation number of polyatomic ion is equal to charge. So the oxidation number of SO4 2- is -2. Similarly, carbonate ion CO3 2- is -2. Let us discuss some examples. Potassium manganate K2MnO4. So here Mn is underlined. So we have to calculate the oxidation state of Mn in potassium manganate. So how can you calculate? For that, so we are having 2 potassium. So 2 into, we studied for potassium the oxidation state is +1. So you have to write like this, 2 into +1 plus. So we are going to calculate the oxidation state of manganese. So it is X plus 4 oxygen. So 4 into, for 1 oxygen it is -2. So we studied the algebraic sum of oxidation state of all the element is equal to 0. That is 2 into +1 +2 plus X 4 into -2 -8 equal to 0. Therefore X equal to +6. So +6 is the oxidation state of manganese in K2MnO4. So let us do one more example. Oxidation state of manganese in potassium permanganate. As usual, only one potassium, so +1. Plus manganese, we have to calculate X. For 1 oxygen -2, there are 4, therefore it is -8 equal to 0. So X minus 7 equal to 0, X equal to +7. So +7 is the oxidation state of manganese in KMnO4. Do problem number 8.1 and 8.2 of exercise in NCERT class 11 part 2 textbook as a homework. Stock notation. So what is stock notation? Representation of oxidation number of metal in a compound is known as stock notation. For example, we are having a compound called AuCl. So in AuCl, which is the metal? Gold. Au is the metal. How can you represent? So first we have to calculate the oxidation number of Au in AuCl. How can you calculate? X. For chlorine we know -1 is the oxidation state. So X is equal to 0. Therefore X equal to +1. So now stock notation means you have to write Au. Then the oxidation state you have to write in a small parenthesis in Roman numeral. Then you write Cl. This is the stock notation of AuCl. That means the representation of oxidation number of a metal in a compound is known as stock notation. Practice problem number 8.3 of your NCERT part 2 textbook.